Matrix. There could be a matrix operation on the problem, which might ask you to do an addition of matrices, a multiplication of matrices, but I'm pretty sure it's going to be phrased in the voice of a application type of problem. The matrix 48, 73, 105 describes the cost of a shirt, a sweater, and a raincoat. At the end of the month, a 25% off sale begins. Use matrix concepts to determine the sale cost of each item. Now, if you want partial credit for this, you can do exactly what we say. Use matrix methods. So, how are you going to approach the problem?
X plus 48x plus 73y.
But this is not really an equation because this is talking about a shirt, a sweater, and a raincoat.
Would you just enter in the matrix and multiply the matrix by 25%?
Okay, so suggestion number 1. Enter the matrix and multiply by 0.25, which is a scalar multiplication problem. So that means that we could go to matrix A and we could say we have 48, we have 73, we have 105, and we can multiply that by a 0.25. But it's a 25% off sale. So this is going to give us,
So we can do 0.75?
better, how much to take off. This would identify how much they're taking off of the price. You'd still need to come back and you would need to subtract this result from the given matrix, making this problem a two-step problem. So I'd have to use two matrices here. The result would have to go into a separate matrix, then I have to do subtraction problem if I'm using matrix methods. So that would be one way to be able to take the problem, one option. But that's two sets of operations. That means I got to do several multiplication problems in there. A second way to do the problem would be to think about handling the subtraction a little bit differently. If it's 25% off, then you're paying what percent?
75.
So maybe we do the subtraction problem on the percentage value, because now coming back and doing a 0.75 times that matrix of 48, 73, and 105 would give us exactly what they asked for more quickly. It doesn't mean you have to do it as a two-step problem. You don't have to do it as a one-step problem. But I can tell you that when you did a problem like this on the exercise, on the test, some of you forgot to add the matrices together. And you ended up giving us only how much it increased or something like that. Or maybe there was a quiz question that was somewhat like this. So in my mind, this would be a better approach, or maybe I would say it's going to be a quicker approach because you're turning it into a one-step operation, actually a two-step operation. Operation step 1, enter the matrix. Operation step 2, multiply that matrix by 0.75. And then you got your answer. This one would be one, however, that they want you to probably create the matrix and enter the values into the matrix. So you have what size matrix to begin with?
1, 3.
It's a 1 by 3. So make sure you put in a 1 by 3 matrix, not a 3 by 1. 3 by 1 would give you a long column. You might have the right numbers, but it'll count it wrong, and then I got to go back and give you partial credit, or maybe full credit, just because you can't tell the difference between rows and columns. Are we going to have a multiplication problem of matrices? We could.